Hello students, welcome to EPG Pathshala. I am Dr. Nimisha Jadon, working as an assistant professor in a School of Studies in Environmental Chemistry, Jivaji University, Gwalior. Today we shall learn about the analysis of water pollutants and the objective of water analysis. This module comes under the paper of environmental analysis. Now we have discussed about the learning objective of this module. We shall learn in this module what is the objective of water analysis, the important feature of water analysis, sampling, the various techniques that we are using in the sampling, and the preservation of sample. This whole contents we have discussed in this module. Water resources degraded continuously by the natural and the anthropogenic activities, and it deteriorates the quality of water and push them to extend to the unplanned development. So there is a need to the specific conservation strategy, because the deterioration in the water quality alter their quality, and again it's imbalance the ecological balance. The objectives of carrying out the physicochemical and biological analysis of water bodies is to assess or evaluate the water quality, which leads to information about their misuse by indicating the pollution status, and to determine the quality of aquatic life, which depends on the water quality. A thorough assessment of the water quality is an integral part of the evaluation. The assessment of chemical criteria of the water body helps in evaluating the chemicals that causes toxicity to aquatic life, to studying the long-term effects on the ecosystem, for conducting the status and monitoring of water resources by studying their physicochemical and biological parameters. Different types of examinations such as physical, chemical, biological and macrobiological analysis of water are necessary, because to analyze the qualitative and quantitative aspects of plankton population of the water body. In many cases, planktons also act as a biological indicator of pollution and being very sensitive to changes in water quality. It is also essential to assess its quality to provide a pure and wholesome water to the public for drinking and other domestic purposes. It is also required to find out whether a water is suitable for the specific industrial purposes, and if not so, to choose the most effective treatment processes. It is also necessary to determine whether any pollution has occurred in watercourse, and to trace the origin and extent of pollution, and to suggest a possible remedy. It is also essential to determine the efficiency towards natural purification when the sewage and the industrial wastage are discharged into the watercourse. It is also essential to ascertain the effect of heavy rainfall of long continued drought, and it is required to measure the effect of pumping, particularly when the wells are constructed near the sea or an estuary where the tidal influence is possible. Analysis is also necessary to check the efficiency, uniformity and consistency of treatment and purification processes. It is also required to find out the possibility and extent of mixing water from two or more sources. It is also need to find out whether the infection by the microbial organism has occurred, and if so, to find out the particular organism and to suggest preventive measures and effective disinfection procedures. Sewage and other wastewater are also analyzed to determine the influence of them on receiving waters, and as far as possible to protect the source from contamination. They are also examined to ascertain whether the treatment plans are working satisfactorily or not. Water is a dynamic medium and its quality varies spatially and temporally. In order to characterize any water body, studies on the major components like hydrological, physicochemical, and biological characteristics should be assessed or carried out before or prior to the analysis of any wastewater or water sample. The important feature of sampling includes the hydrological feature. First of all, we have discussed about the hydrological feature of any water body. Each of the inland water body is characterized by its unique hydrological features, such as rivers characterized by the unidirectional current with relatively high average velocity up to 0.1 to 1 meter per second. In general, thorough and continuous vertical mixing is achieved in rivers due to the prevailing currents and turbulence. Lakes are characterized by low average current up to 0.001 to 0.01 millimeter per second, giving high residential time for water, and currents within the lakes are multidirectional with mixing regulated by the climatic condition and lake depth. The groundwater is characterized by a steady flow pattern both in direction and speed that is largely governed by the porosity of the geological material, as a result of which the mixing is poor. Reservoirs are the intermediate between the rivers and lakes. The hydrodynamic characteristics of each type of water body are highly dependent on the size of the water body, climatic condition, and the drainage pattern associated with it. Groundwater greatly depend on the recharge regime, that is infiltration through unsaturated aquifer zone that allows renewal of the groundwater. Physical, chemical, and biological properties of wastewater analysis. The physical and chemical properties of a freshwater body are characteristics of the climatic, geochemical, geomorphologic, and pollution conditions prevailing in the drainage basin and the underlying aquifer. The biota in the surface water is governed entirely by various environmental conditions that determine the selection of species as the physiological performance of the individual organisms. The primary production of organic matter in the form of phytoplankton, macrophytes, is more intense in lakes and reservoirs than in rivers. In contrast to the chemical purity of water body, which can be measured by suitable analytical methods, biological quality is a combination of both qualitative and quantitative characterization. This can be carried out in two levels. Number one, response of individual species to change in its environment, and number two, response of biological communities to change in their environment. Now we have discussed about the sampling. The samples are the representative of the whole water body that we want to analyze. The sample should be small in volume, but it should be representative of the whole water body, whatever it could be, a lake or the river or the potable water. The integrity of the sample should be maintained till we have taken the sample and up to the when we have analyzed the sample. So the sampling should be done in this way that the natural integrity of water sample kept constant, and this sample have the tendency to accommodate itself in the new environment. So the natural constituents of the sample would not be changed when we take the sample and take it into the laboratory for the analysis. Before collecting the samples, the line should be flushed for sufficient period of time. The most convenient point of sampling of potable water is the consumer's premises. The sample should possibly be taken from the tap directly connected to the main tap. Details regarding the position of the premises relative to the supply main and its possible permeability to a dead end are to be noted while such samples are taken. The important features of the sampling includes the frequency of sample collection, the total number of samples, the size of each sample, the sites of sample collections, data to be collected with each sample prior to analysis, and quantity of sample. Generally, 2 liters of sample are sufficient for most of the physical and chemical examination for certain spatial determination. However, large volumes of the samples are necessary. The essential objectives of water quality assessments are to define the status and trends in water quality of a given water body, to analyze the causes for the observed conditions and trends, and to identify the area specific problems of water quality and provide assessments in the form of management to evaluate alternatives that help in decision making. Water quality assessment is also necessary for evaluating the chemicals that causes toxicity. The studying the long-term effects on the ecosystem is also done by determining or characterize the water sample present in the particular ecosystem. The analysis is also necessary for conducting the status and monitoring of water resources by studying their physical, chemical and biological parameter, and to analyze the qualitative and quantitative aspects of that particular water body. Now the next step is the site selection. We have chosen the 3 points. The number 1 is inlet, from where the feed the wastewater and the other water into the natural water body. Then the second part is the center of the water body, where it represents the natural or the whole constituent of the water body which we want to analyze. And the third one is the outlet. From this is the point from where this outflow is maximum, and we can get the exact quality of water in whole the 3 points of sampling. So that's why we because we want the representative sample, we have chosen the whole the 3 sites of sampling. Now we have discussed about the types of sampling. The sampling is of 2 types mainly, the grab sampling and the composite sampling. The grab sampling is also known as the spot sampling and instantaneous sampling. The grab sampling is the sample that is collected at a given point of the sample site and at a given time. We have taken the grab sample when we want to collect the sample of a small water body. For example, the grab sampling is done either for the potable water and for the when we want to analyze the groundwater. But the composite sampling is the way of sampling. We have collected the 4-5 samples at a time in the time interval of either in 12 hour or the 24 hour, and then we can mix all the sample and make a homogeneous sample, so that this sample is the representative of whole water body. Composite sampling is always done in the big water streams and the rivers, and because it could be a representative of whole river body. And the third one type is the integrated sampling. It is a type of mixture of composite and grave sampling, where we have collected 4-5 grave sample simultaneously at the with the different sites of water body. After the site selection, now we have come to the sampling equipment or samplers which is required to collect the sample. The number 1 sampler which we are using for sample collection is the depth integrating sampler. It is a device which is made up of iron and painted with a rust inhibitor. Typically, this design permits the use of 2-liter sample bottle when the bottleneck hold is in the upper position. A smaller bottle may be used when the holder is located in the lower position. The sample bottles are placed in the sampler and secured by the neck holder. A depth integrated samples is taken by permitting the sample to sink to the desired depth at a constant rate and then retrieving it at approximately the same rate. The rate should be such that the bottle has just been filled when reaching the surface. In this figure, we have seen that the collecting vessel is connected with the rope, nylon rope, and we insert this vessel vertically down to the water body, and then we insert the cork and pull back to the water body so that water sample is collected in the vessel and it will not deaerated by the atmospheric air. The second one is the discrete sampler. It is used to collect the water at specific depth. An appropriate sampler is lowered to the desired depth and activated retrieved. The sample should be taken at a known depth and without aeration. Depth sampler can be collected with a bottle which can be closed by a stopper and controlled by cord, permitting samples to be taken at any given depth. This is the picture of discrete sampler. Here we have seen that the discrete sampler is made either we have container that we are using in the discrete sampler is made up of glass or the polyethylene, and this sample is particularly used when we want to collect the sample from the depth of the water body. So in the upper lid is attached with the spring. As we pull down the sampler into the water body, the lid is open automatically and the water is collected into the container, and as the container filled with water, it is automatically close the lid and we can pull out the sampler by using the mechanically connected rope, so we can get the sample in their original condition. Now the third one is the displacement or DO sampler. Sample must be collected without causing any change in the DO concentration. Contact time with air or agitation has to be avoided because it will change the concentration of dissolved oxygen in the water sample. The liquid can siphon through a glass or the rubber tube into the sample bottle. The sampling of shallow stream is not advisable with the use of this sampler. In this figure, we have seen the displacement and the DO sampler. In this figure, the small cage contains the 300 ml BOD bottle, and as we pull down this DO sampler into the water body, automatically the water is siphoned through the tube into the BOD bottle, and as the water is filled up to the level, the rubber cork stop this BOD bottle so that the atmospheric oxygen cannot be affected the natural constituent dissolved oxygen present in the water, and then we can pull out by using the rope connected with this sampler. Now we have discussed about the sampling of the potable water. When the liquid is homogeneous, it is sufficient to take the grape sample, and if the liquid is flowing along the pipe or channel or over a weir, that can be taken by means of a wide-mouthed vessel. The bottle first should be rinsed with the liquid that being sampled and then filled. When the liquid to be sampled is heterogeneous such as sewage, the composite sampling is necessary for the further analysis. If any constituent to be determined is affected by the air contact, take the sample out of contact with air and completely fill the container with the potable water. Before collecting the sample, the inside and outside of the tape should be thoroughly cleaned, and the water being sampled should then be allowed to water for some time so that the sample will be representative of whole supply. If water from a well is to be collected, then the well has to be pumped for a sufficient period of time so that the sample represent the groundwater that feed the well. Now, we have discussed about the sampling of water bodies. Because of a wide variety of conditions found in streams, lakes, reservoirs, and other bodies of water, it is not possible to prescribe the exact point of sampling. The choice of location, depth, and frequency of sampling should be bound or local conditions and upon the purpose of the investigation. A sample taken at any point in the cross section is satisfactory in the case of a stream where water is mixed to uniformity. This uniform mixing cannot be expected in large rivers and streams, and 3 or more samples are taken at the midpoint of equal cross-sectional area of such rivers and streams. These samples are then combined together to obtain a composite sample. Now we have discussed about the sampling of sewage sample. The standard method of sampling sewage involves the collection of composite samples over a 24-hour period. The sampling frequency is essential for assessing the quality of water varies with the time in the water body due to the various natural and human-induced factors. The monitoring has to be done in a way that records all the changes in the quality. The sampling frequencies generally adopted in monitoring are weekly sampling for 1 year, consecutive day sampling during study period, hourly sampling for 24 hours, and monthly sampling for predefined time. Variation in water quality are mainly due to the change in the concentration of the components of the water flowing into the water body. These variations can be man-made or natural and can either be cyclic or random. The random variation occurs due to the spasmodic, often unpredictable events such as accidental oil spills, sewage leak, overflows, etc. And the cyclic variation occurs may be a result of regular seasonal changes triggering certain natural processes such as rainfall, snow melts, and seasonal temperature changes altering the ecosystem. Seasonal growth and decay of vegetation will also rise due to the cyclic changes in the composition of water. Now we have discussed about the sampling container. The sampling container should not react with the sample. It is having an adequate capacity to store the sample, and it is free from any kind of contamination. After that, we have used some preservation technique to preserve the sample prior to the analysis, because there is a time gap when we have collected the sample and after that we have taken it to the laboratory and doing the final analysis. Filling up this gap, we need to preserve the sample so that the original content of the water preserved and we can assess the real content of the water sample. The preservation is required between the time a sample is collected and analyzed in the laboratory. The physical, chemical and biochemical reaction may take place in the sample container, leading to the changes in the intrinsic quality of the sample and making it necessary to prevent or minimize these changes with suitable preservatives such as alcohol and mercury chloride. Highly unstable parameters such as pH, temperature, transparency, free carbon dioxide, dissolved oxygen, etc. are measured at the sampling site. The preservation procedure include keeping the samples in the dark, adding chemical preservatives, lowering the temperature to retard reaction, or combination of all these processes. Here is the table which shows the various preservation methodologies that we have followed prior to the analysis. For example, for the beauty determination, we have to keep the sample at 4 degrees centigrade and the maximum holding capacity is 4 hours. It means we have to determine the BOD after collection of the sample within the 4 hour, and after that its quality of water or the organic content of water could be changed. Calcium is also used as a analyzing parameter, and preservation techniques for used for it is again a cool the temperature up to 4 degrees centigrade and holding capacity is 7 days. Similarly, we have followed for chloride also, fluoride, manganese and other parameter. COD we can preserve for by the cooling of the temperature or by the addition of 2 ml of H2SO4 per liter of sample, and it has to be determined within 24 hours of the sampling. The dissolved oxygen has to be fixed on the site, and after that we can analyze the DO within the 6 hours of the sampling. Nitrate and nitrite also fixed at the time of sampling, and it is also determined within the 4 hours of the after the collection of the sample. The other parameters like phosphorus, dissolved, inorganic and orthophosphorus, these all are cooled at 4 degrees centigrade and determined within a 24 hour of the period. Heavy metals we can preserve by the addition of 2 ml of concentrated nitric acid per liter of sample. Heavy metals like cadmium, chromium, copper, iron, lead, nickel and zinc, they all heavy metals can be preserved by the addition of 2 ml of concentrated nitric acid per liter of sample for the 6 months of period. It means we can determine the heavy metal after the collection of the sample duration of 6 months. We can determine any time, so it's a long period of preservation. So heavy metal we can say preserve for the long period of time, and the other parameters has to be determined within the 24 hours of the collection of the sample. So students, at the end of this module, we have summarized the whole content that we have learned in this module. In this module, we learn about the importance of or the objectivity of water analysis, because the water is an important constituent of the environment and it is now an essential part of the human life also. So first we have to analyze the water before it is used for the drinking purposes or as to the industrial purposes. We have also learned about the methods of sample collection of the various water bodies, either it will be a potable water, groundwater or industrial water or the river water. So we have learned the various sampling techniques of this water sample and the importance of this sampling in the water analysis. And afterwards we have learned the various preservation techniques which we are using to maintain the quality of the constituent as it is, that they present naturally in the water body, so that the preservatives we are using for the purpose of constituents present in the water in a natural condition. Thank you so much.